So in this video, we're going to talk about the integrals of hyperbolic functions. Again, we're not going to go too in depth as this part of the course is not really heavily dependent upon. Okay, and so the two ones we need to really know is that if I take the integral of cosine hyperbolic of x, well, that happens to be sine hyperbolic of x plus c. Okay, we need to know that. Vice versa, if I take the integral of sine hyperbolic of x, well, that's just cosine hyperbolic of x plus c. Okay, so with that being said, let's look at some examples. So what if I want to take the integral of sine hyperbolic of 2x dx? Okay, what would be my integral? Well, we know the integral of sine hyperbolic of 2x. That happens to be cosine hyperbolic of that same thing, right? But because I have a 2 here, which represents my chain rule, I got to multiply this by 1/2. So it becomes 1/2 cosine hyperbolic of 2x plus c. Okay, and notice if I take my derivative, the derivative of cosine hyperbolic of x of 2x is a sine hyperbolic of 2x, which is here. And then we got to take, remember, this is a chain rule problem, so we got to take the derivative of the inside, which is 2. But the good thing is that if we multiply by 2, we have this 1/2 here that cancels out. And so we get back our original function. Let's look at another one. What if I wanted to take the integral of cosine hyperbolic of 1/5 x dx? Okay. Well, we know the integral of cosine hyperbolic of 1/5 x. And that happens to be sine hyperbolic of 1/5 x. Okay. But remember, we have 1/5 here, so we got to multiply by 5. We attach on our plus c. And why do we do that? Well, if I take my derivative of sine hyperbolic of 1/5 x, now I get cosine hyperbolic of 1/5 x. And then we have our chain rule that we got to multiply by the derivative of the inside, which is 1/5. Okay, well, the good thing is that I have a 5 here. So 5 times 1/5, that's just 1. That will give me back my original function. Okay, so again, hopefully you could see the pattern here. So let's look at one more. So what if I wanted to take the integral of x sine hyperbolic of x squared dx? Okay, what would be this? Well, to me, this looks like a u substitution problem. And so if I set my u to be x squared, then I know my du is 2x dx. Well, I have an x dx and not a 2x dx. And so if I divide by 2 on one side, I get 1/2 du to be x dx. So 1/2 du is what I'm substituting in for x dx. And so if I rewrite our integral, this becomes 1/2. Okay, this becomes sine hyperbolic of u du. Okay, because remember, u is x squared, and we attach our du here. Okay, so what's the integral of sine hyperbolic of u? Well, that happens to be 1/2 cosine. Yeah, that happens to be 1/2 cosine hyperbolic of u plus c. Okay, well, what was our u? X squared. And so our final integral is defined to be 1/2 cosine hyperbolic of x squared plus c. Again, I don't think your teacher will give you anything that's complicated. We just need to know the basic integrals of these functions.